In this example, we're going to look at how we could use the double angle formulae. So, given that theta is acute with sine theta is equal to 4/5, we've got to calculate sine 2 theta and cos 2 theta. So instantly you should be looking at your formula sheet there. So to calculate sine 2 theta, we're needing 2 sine alpha cos alpha, or sine 2 theta cos theta. Now we've only been given sine theta, so we have to work out cos theta. In this case you should always draw a right angle triangle. So if we draw a right angle triangle and we mark in the opposite and the hypotenuse, because that's really what sine means, it's a ratio of the opposite to the hypotenuse, we can then calculate the other side in the right angle triangle with a bit of Pythagoras. And that would give you this idea here. There's your opposite and your hypotenuse, 4 and 5, and the adjacent must be 3. And from this we can calculate that the cos of theta is equal to 3/5. So there's an expansion there from the formula sheet, the sine 2 theta, or sine 2 alpha in this case, looking here. And then we can say that, well, that's equal to the 2 times 4/5, and the cos of theta is 3/5, so we need to multiply it by 3/5. So that's the same as 2 times 12/25, which is 24/25, and that's your answer. Now we turn our attention to cos 2 theta. Now we've got 3 options here. Every one will work. There's not one that's better than the other. However, I like to choose the top one because you don't end up doing fractions take away whole numbers or whole numbers take away fractions. I think it's easier. But it doesn't matter, any one will work. So I'm going to choose the expansion cos squared theta minus sine squared theta. We know already that sine theta is 4/5, and we've worked out that cos theta is 3/5. So this is really 3/5 squared minus 4/5 squared. When you're squaring a fraction, this is really 3/5 times 3/5. So you're squaring the top number to get 9 and the bottom to get 25. So that's really 9/25, and this is going to be take away 16/25, and that leads to -7/25, and you're finished.